In 2025, Chinese consumers purchased more than 282 million smartphones. Huawei sold 46.8 million units, overtaking Apple and reclaiming the #1 position after 5 years. But 6 years earlier, the company seemed close to collapse. In 2019, the United States placed Huawei on its entity list, cutting its new phones off from Google services and restricting access to advanced chips and manufacturers using American technology. A smartphone giant that once competed directly with Samsung and Apple was suddenly pushed out of the global market. Yet Huawei survived. It developed Kirin chips, built HarmonyOS, and brought more than 350,000 apps and services into its own ecosystem. How did Huawei turn a technological death sentence into such a remarkable comeback? Before 2019, Huawei already had the ability to design chips, manufacture smartphones, and build telecommunications equipment on a global scale. However, this system still depended on several critical links outside China. Kirin chips required advanced foundries for production, Huawei's international phones relied on Google services, and its apps depended on a software platform the company did not fully control. When these links were cut off, Huawei could not simply switch suppliers. The company was forced to rebuild several layers of technology at the same time. HiSilicon continued developing chips, SMIC took over production, while HarmonyOS and a new app ecosystem gradually began to take shape. It became a race on several fronts, with chips, software, and market growth all needing to move forward together. This process ultimately brought Huawei back from the brink of being pushed out of the industry to the leading position in China. On May 16, 2019, the United States placed Huawei and dozens of related companies on the entity list. From that point on, any products, software, or technology covered by U.S. export controls required a license before they could be supplied to Huawei, and most applications were reviewed under a policy of denial. A decision made in Washington immediately sent shockwaves through the global technology supply chain. The first impact appeared on the screen. Google could no longer work with Huawei on its new devices. New models lost access to Google Play, Gmail, YouTube, and Google Maps. Huawei could still use the open-source version of Android, but that was only the basic framework. Many apps also depended on Google Play services for login, notifications, location tracking, and payments. The phones could still turn on, but their connection to the global digital world began to break apart. In 2020, the United States expanded the foreign direct product rule. Even chips manufactured outside the country could be restricted if their production relied on American technology, software, or equipment. The restrictions therefore reached chip foundries across Asia. HiSilicon could design Kirin processors, but Huawei did not own factories advanced enough to turn those designs into millions of chips. Once international foundries were required to obtain licenses before continuing production, the path from chip design to finished wafers was nearly blocked. Huawei relied on its stockpiled chips to buy more time, but those reserves gradually ran out. Supplies of advanced 5G processors became limited. Its international smartphones lost competitiveness, and the company's market position collapsed. This raised a critical question. How could Huawei manufacture advanced chips when the best tools were beyond its reach? A modern chip is smaller than a fingernail, yet it contains billions of transistors across dozens of circuit layers. A silicon wafer must pass through hundreds of stages, including material deposition, exposure, etching, ion implantation, cleaning, and inspection in an almost completely dust-free environment. Design is only the beginning. To manufacture millions of identical processors, Huawei needs a factory where every machine operates with extreme precision. A deviation of just a few nanometers can ruin the product. The hardest equipment to replace is the lithography machine, which uses light to print circuit patterns onto a wafer. Smaller transistors allow manufacturers to fit more computing power into the same area, increasing performance while reducing energy consumption. The most advanced production lines use ASML's EUV technology, which produces light with a wavelength of 13.5 nanometers. Lasers strike tiny droplets of tin to create plasma, while a system of mirrors directs the light through a vacuum and aligns each circuit layer with near-perfect accuracy. China cannot access advanced EUV systems. Export controls also cover etching machines, deposition equipment, measuring tools, defect inspection systems, and chip design software. The obstacle therefore extends across the entire network of tools behind the production line. The remaining option is to use older DUV machines and divide each pattern into several exposure stages. This makes production slower, more expensive, and more vulnerable to alignment errors. If too many chips on a wafer fail, production yield falls, supply shrinks, and the cost of every working processor rises sharply. In late August 2023, Huawei suddenly launched the Mate 60 Pro in China without holding a global event. From the outside, it looked much like any other flagship phone. But when experts opened the device, they found something the semiconductor industry did not expect Huawei to restore so soon. The Kirin 9000S, a processor capable of supporting 5G connectivity. The chip was designed by HiSilicon and manufactured by SMIC, using its N+2 process at the 7-nanometer level. Tech Insights found that the chip die measured about 107 square millimeters and combined the CPU, graphics processor, modem, and billions of transistors. At the time, it was the most advanced confirmed chip produced by a Chinese foundry. The Kirin 9000S could not yet match the most powerful processors from Apple or Qualcomm. SMIC's process required more manufacturing steps, increasing both costs and pressure on production yield. Even so, Huawei had restored the link between HiSilicon's designs and a commercial processor that could power a 5G smartphone. Kirin was officially back. After the Mate 60 Pro, Huawei introduced the Kirin 9010 in the Pura 70 series. In late 2024, the Mate 70 Pro Plus arrived with the Kirin 9020. These chips did not represent a complete move to a new manufacturing generation, but a series of gradual improvements in processor layout, performance, and operation on existing production lines. Huawei's engineers did not wait for perfect equipment. They adapted their designs to the tools available, balancing speed, heat, power consumption, and chip size, while the factories corrected defects through each new batch of wafers. The Mate 60 Pro proved that Huawei had restored the most difficult link between semiconductor design and manufacturing. Hardware can make a device run, but keeping users requires control over the software above it. In August 2019, Huawei introduced HarmonyOS. It was initially designed for smart displays, watches, and home appliances. In June 2021, HarmonyOS 2 officially arrived on smartphones and tablets in China. The early versions offered Huawei's own interface, account services, and device connectivity, while still supporting many Android apps. This provided a necessary transition, but Huawei still did not control the entire software foundation. The turning point came in 2024 with HarmonyOS 5, previously developed under the name HarmonyOS Next. Huawei moved toward a fully native app environment. Applications now had to be written, compiled, and tested specifically for HarmonyOS instead of simply installing Android packages. To support this change, Huawei built a complete software development system. Developers use ArcTS as the programming language, ArcUI to create interfaces, and Devico Studio to write, compile, and test code. The HarmonyOS SDK provides essential platform functions. Huawei was building more than an operating system. It created the languages, tools, libraries, and development environment needed to support it. HarmonyOS also connects different devices, allowing a task started on a phone to continue on a tablet or another screen. Instead of operating as separate devices, they work together as one connected network. Huawei finally had a software platform of its own. Even the most advanced operating system can fail if users cannot find the apps they need every day. This challenge has defeated many new platforms. Developers avoid systems with too few users, while users avoid phones without familiar apps. Huawei therefore focused first on essential services in China, including communication, payments, banking, e-commerce, transportation, entertainment, and public services. Moving these apps to HarmonyOS required more than reusing Android code. Developers had to rebuild interfaces, login systems, payments, notifications, maps, location services, and storage using Huawei's tools. The company supported them with documentation, testing systems, training, financial incentives, and promotion through App Gallery. Huawei also introduced atomic services, small functions that can appear when needed without installing a full app, such as booking tickets, tracking orders, or making payments. By the end of 2024, HarmonyOS 5 had more than 20,000 apps and atomic services across 18 categories. 1 year later, over 36 million devices were running HarmonyOS 5 and 6. Registered developers exceeded 10 million, and App Gallery offered more than 350,000 apps and services. The ecosystem began to accelerate. More apps attracted more users, while a larger user base encouraged developers to keep investing. Huawei had created the software foundation needed for its return to the smartphone market. In the first quarter of 2025, Huawei's smartphone sales in China rose 28.5% year-over-year, pushing the company into first place and giving it its highest market share since 2021. Government subsidies helped stimulate demand, but Huawei could only benefit because its supply had become more stable. By the end of the year, the recovery was clear. Mainland China shipped about 282.3 million smartphones, down 1% from the previous year. Despite the weak market, Huawei sold 46.8 million devices, captured a 17% share, and returned to the top position after 5 years. Vivo followed with 46 million units, while Apple sold 45.9 million. Fewer than 1 million devices separated the three leading brands. The narrow gap showed that Huawei had not completely dominated the market. In the fourth quarter of 2025, Apple led with 16.5 million iPhones and a 22% share, while Huawei shipped 11.1 million devices and ranked fourth. A new iPhone generation proved that Apple could still fight back strongly within a single quarter. However, Huawei's full-year victory carried greater meaning. Technologies that had once existed mainly in laboratories were now reaching the market through tens of millions of devices. In the first quarter of 2026, Huawei remained China's leading smartphone brand, shipping 13.9 million units and capturing about 20% of the market. The company had fully returned to the race. Sales alone cannot answer the whole question. Behind Huawei's smartphones are still machines, materials, and technologies that China has not fully replaced. A smartphone contains thousands of components and depends on patents, materials, and tools from a global network. Technological independence does not mean producing every part domestically. What matters is whether a company can continue operating when a supplier or country leaves the chain. In semiconductors, Huawei now has greater control over chip design and access to domestic production for high-end phones. SMIC has also advanced to its N+3 process to manufacture the Kirin 9030 for the Mate 80 series. However, transistor density still remains below the leading 5nm processes used by TSMC and Samsung. The gap has narrowed, but it has not disappeared. Huawei can bring advanced products to market, but at higher costs with limited production capacity and greater pressure on energy efficiency. This is resilience against disruption, not complete technological leadership. In software, Huawei has more control because it owns the development environment, distribution system, and core services. However, this strength remains concentrated in China, where HarmonyOS has a stronger user base. In many international markets, Android and Google services remain deeply established. Huawei is expanding its independence through massive investment. In 2025, the company spent 192.3 billion yuan on research and development, equal to 21.8% of its revenue. The funding supports smartphones, Ascend AI chips, Kunpeng servers, cloud computing, smart vehicles, and industrial equipment, allowing advances in one field to strengthen the others. Huawei is not completely independent, but it has transformed from a vulnerable system into one capable of surviving, adapting, and continuing to grow under pressure. That may be its most important achievement. 6 years have turned Huawei into an unprecedented industrial experiment. Its greatest achievement is not a position in the rankings, but its ability to keep moving after the familiar path was blocked. Huawei still has major gaps to close. Yet every limitation is no longer just a wall. It has become a new engineering challenge that forces the entire system to adapt. Do you think this model can bring Huawei back to the global market? Or will it only create a powerful ecosystem within China? Share your thoughts in the comments, and remember to like and subscribe to Mandarin Tech as we continue exploring the technology races quietly reshaping the world.